All right. Please, and tell me your name again. Is it Gabe?
Chad.
Chad. 4 letters. Just the wrong 4 letters. Go ahead.
So, let's see. I did 7/10 minus 2.
Oh, this guy over here. X over 3, 7/10 minus 2.
Yep.
Good.
And that's negative 13/10.
Say that again.
7/10 minus 2 is negative 13.
How did you get that so quickly?
Because 7/10 minus 1 is negative 3/10, and then I added 3 more, or 10 more. 10.
Very nice. Couple ways to attack this. Couple ways to attack this. And as Americans, we're unfortunately disadvantaged because we're not used to the metric system. 7/10. One way of looking at 7/10 minus 2 is to change 7/10 to 0.7. That's one way to deal with it. 0.7 minus 2, which would be 2.0, which would be negative 1.3. That's one way of dealing with it, if you want to change it to decimals. You don't have to. I'm just saying that's one way of dealing with it. You don't have to do it that way. Another way is to leave it as the fraction that it is. That's what Chad did. So 7/10, if you want to take 2 away from 7/10, you want to make sure that you get it having a denominator of 10. That's one of the things you have to do. You can't talk about pizzas if you're talking about adding slices of pizza together until all the slices are the same size. At least you shouldn't mathematically. So 7/10, how many tenths is 2? 20 tenths. So 7/10 minus 20 tenths. It's hard to say. Negative 13 tenths. Which is the same, if you change it to a decimal, as negative 1.3. Who would go with the decimal? Who would go with the decimal in this case? Well, one of us. Fraction? Okay.
They forced you. I think
they forced you to?
were trained in college up here. You
Well,
go all the way from the bottom of the math and work your way up.
Can anybody think of a reason? Tell me your name one more time. Brittany, thank you. Why, as Brittany says, why do they train you with those fractions from a very early age and make you keep doing it? Why, how come? Is there any disadvantage to doing the decimal conversion? Is there any disadvantage to doing the decimal conversion?
Oh yeah, because you have to usually you have to pick up tenths or hundredths or
well, good. Yes.
And so that gives you a straight number.
That's true. Like we saw up here, you can't actually write 16/6 as an exact decimal. It has to be either a repeating decimal. You can write it as 2.6 repeating. And you can actually put an equal sign next to that because that is equal to 2.6 repeating. But the problem with that is, very often when you take these fractions to do something with, like yesterday I was putting the irrigation together in our side yard, with zero escaping all over the yard, which is great, except every winter when we go out there and shovel the snow, we end up breaking a whole bunch of them off. And we have to lay some of the pipes down again and cut to length. A lot of times, you have to figure out how much pipe do I need. I got 1/2 foot here, I got 3.5 feet here. And, very often, if I got 2/3 of a foot or 2/3 of a yard, you have to round those things off. You can't go into Lowe's and be like, I need root 5 feet of PVC. Because they're like, get the hell out of here. How much PVC do you need? Oh, like 2.5 feet. Oh, here you go. So, a lot of times, if the fractions are nice or if the decimals are easy to get to, they're more practically useful. Fractions are always exact, which I think is why they always, in math classes, they like to really make you do that. Well, I don't know, it's fun. I'm like, your word, I'm not sure if it's forcing. Maybe it is. Don't point that thing at me.
Most of them asked us to always put it in fractions.
Maybe. My point is you can choose. And very often a decimal is an easier way to proceed from this point. So, are we going with fraction or decimal? Just, what the hell, let's do it both. So now we're at x over 3 equals either negative 1.3 or x over 3 equals negative 13 over 10. That's totally fine. Either way you decide to attack it, what's the next step? Yeah, don't overthink this, right? You have to get rid of that divided by 3 bit. Because all we just did, the discussion we just had, wasn't even involving the variable. It was just about getting this guy behaved. So now we have to undo this divided by 3. So since x has been divided by 3, we have to multiply by 3. Kelly, you said something cool on Wednesday. You said, well, this is x, and I know that this number has to be negative 1.3, and this is divided by 3. So I got to think of something that's 3 times bigger. No, you told me on Wednesday-ish. You told me something like that on Wednesday, where you were doing the math kind of conversationally, which was awesome. But it's exactly right. This number is negative 1.3. It has to be 3 times bigger because it's been cut in thirds. So this way, you'd get what? Negative 3.9 on that one. Or if you did it as far as a multiplication over here, or x equals, what's that going to be? Negative 39, sorry, I got equals, negative 39 tenths, which is the same thing as negative 3.9. Your choice. Your choice is which one you want to write. Doesn't matter to me. They're equivalent to each other. And they are exactly equal. Because dividing a number by 10, a fraction that divides a number by 10, is extraordinarily nice. The Europeans have figured this out for years and years and years in the metric system. Changing things from different lengths in a metric system is amazingly simple compared to what it is in American. In the imperial system, I believe it's called the imperial system or the British system or whatever. Because you just move decimal points. Divide by 10, 1 to the left. Divide by 100, 2 to the left, and so forth. Doesn't make any sense to us. How much do I weigh? Ish. Wait. Who was thinking pounds in their mind when I said that? How much do I weigh? You're like, I don't know how many pounds he weighs. 150, 160, 200. Anybody thinking kilograms? Probably not, because we're not trained to think in terms of kilograms. Even though when you go to the store, you buy a 2-liter of soda. I never quite figured out how that measurement somehow got. You buy a 2-liter of soda and a gallon of milk. Never understood how the differences there, the historical differences of how they measured quantities. Sometimes we mix our metrics in. Strange. How about this one? What do you do, Tammy?
10x equals 21.
Ah, the old means extremes. Michelle, right? Michelle, we brought this up last time. When you have a proportion, you can do something called the means extremes. You guys call it cross multiplication. Totally fine. Totally fine. And you can multiply across the diagonals to get 10x equals 21, like that. Totally fine. So what's x? Right, 2.1 or 21 tenths. Perfect. Perfect. Is that Lego approved? It's actually not. It's not. The Lego method of solving equations directly undoes the variable expression. You're actually kind of, it's partially Lego approved, but you're creating another step that didn't happen upon this. So the idea is Lego approved would ignore the 7/10 altogether and say, you know what, that's a number over there. That's it. Lego approved says, don't worry. The Lego method says, you know what this is? It's x over 3 equals something. That's what the Lego doesn't care what's on the right-hand side of an equation at all. It doesn't care. It looks only at the variable expression and says, how can I undo that? How can I undo that? So then you focus just on this, and you say, oh look, it's been divided by 3. That means I must have to multiply by 3 to get rid of it. So x becomes 3 smiley faces. So you just apply that over here. You multiply both sides by 3. 3 times 7 over 10 becomes x equals 21 tenths, or 2.1, depending on how you look at it. Straightforward, pretty straightforward. What I don't want you getting confused with, and this I think some students do get confused with this, is trying to do, this is why I don't teach the cross multiplication anymore, because students always want to use it, and they'll inadvertently use it right here, at the first step. They'll multiply both sides by 3. And go, oh, it's x over, well, x equals 21 tenths minus 2. And they'll forget that the 3 also would have to multiply that 2 that's out there. So that's why I don't really, Lego. Everything's about Legos. It's all about taking apart what you've put together. And whether it's quadratic, whether it's exponential, whether it's linear, it's all about taking it apart. It's all about taking it apart. Cool? Okay, so far? Okay. Now, the bottom 6